Coming up next on Passion Struck.
When children can't read, we get mad at the adults. And when children can't solve math problems, we don't get mad at the adults. We just absolve the children of building a math mind. And we think adults pushing on it are being mean to the kids, right? That's so weird. And I think we should have much higher expectations of the adults.
Welcome to Passion Struck. Hi, I'm your host, John R. Miles, and on the show, we decipher the secrets, tips, and guidance of the world's most inspiring people and turn their wisdom into practical advice for you and those around you. Our mission is to help you unlock the power of intentionality so that you can become the best version of yourself. If you're new to the show, I offer advice and answer listener questions on Fridays. We have long-form interviews the rest of the week with guests ranging from astronauts to authors, CEOs, creators, innovators, scientists, military leaders, visionaries, and athletes. Now, let's go out there and become Passion Struck. I am so excited today to welcome Shalinee Sharma to Passion Struck. Welcome, Shalinee.
Thank you. Thanks for including me, John. So excited to be here today.
Well, thank you for being such a fan of the show, and it's always great to have fans as guests. I really love that, and I know that our community does as well. So thank you for tuning in and being a regular listener. So I want to start today's interview off, as I often do, by asking you, how did your experience as a child shape your views on education?
Thanks for that question. I love that question. I'm so curious about your answer to that question, and I'm sure a lot of your listeners are going to reflect on this through our conversation today. And I'd love to share my experiences with mathematics. We're going to talk about math learning and the idea that all kids can love learning math, which is a shockingly controversial idea. But my journey with math, I was not a math prodigy. So my journey with math, like many of our journeys with math, was a lot of emotions that were often negative. One of my most vivid memories in math learning is sixth grade. So I had just transferred middle schools and I was the new kid in the middle school. I was really struggling in that school. I'd never moved from classroom to classroom. So just getting my schedule settled and figuring out where I needed to go for my next class was hard enough. And I was really academically behind my peers, which I felt in all my classes, but particularly felt in math class. I had decided pretty quickly that my best chance was just to survive that year. And I had no expectations whatsoever that I was going to be successful. And I'd also pretty quickly figured out in math class that there were math kids and there was everybody else. And I was everybody else. And I remember after a test, my math teacher, Mr. Snyder, who was this amazing, passionate teacher, he asked me to come to his desk for a conference. So I went to his desk and he showed me the test and it had less red ink than usual. And he said, "You did better on this test." And he said, "If you try your best, you could be as good as the boys." And when he said that, he tipped his head in the direction of the group of boys that were like the math kids. They were the best at math and they knew it and they were having a lot of fun in the class. And while by today's standards, that may not be the most sensitive way of sharing the sentiment, it totally blew my mind. Because what Mr. Snyder was saying to me was that first he believed in me. A teacher that was that impressive to me believed in me. And he didn't just believe that I could get a B and survive, but he thought that I could be one of the best. He thought I could understand. He thought I could be great. And I just never even had considered that possibility. It wasn't on the table for me to think about. And I really think those few sentences may have changed the trajectory of my life because it gave me the courage to ask for help. I asked him for help. I asked my parents for help. And I worked really hard. And through the course of that year in sixth grade, I went from memorizing, not understanding, learning the math for a test and forgetting it, to deeply understanding, learning math in a way I can never forget it, just like I can learn to read and never forget it. And actually, I even got to the place at times where I wasn't just doing the math to please Mr. Snyder, though I did very much desire to do a good job for him. I found pleasure myself. I was having a blast just doing the math. And I think that all kids can have that.
Well, for me, I have always done well in math and it always came easy to me. However, as I got more into advanced math and a plus, especially when I was in college and doing applied math, I've started to find that to be extremely difficult because it was using a completely different part of my brain and how I was having to proof those equations than when I was doing algebra or geometry or even calculus. But for me, it's something that, for the most part, always came easy to me. Although I do remember my mom being my primary tutor when I was growing up. And I think for you, it was your father.
Mhm.
How do you think his influence helped you to fall in love with math even more?
I don't have a scientific survey here, but whenever I get a chance to chat with middle schoolers, high schoolers, or grown-ups, other adults who feel positive about mathematics, they always share one additional support that was outside of school. 100% of the time. Every single person. I know you were gonna, I could have asked you who supported you outside of school, and you would have given me an answer. And so I think that's an interesting phenomena to consider. What my dad did when I didn't understand math, let's say I went to math class, I didn't understand it. I came home, I was doing my homework, I was getting frustrated. I just needed 10 minutes of help. I didn't need to redo the fifth grade. And also, that's not practical. I couldn't redo the fifth grade. I was in the seventh week of sixth grade. I needed to do sixth grade. But he sat with me for 10 minutes. That's it. Sat with me for 10 minutes, calmly taught me whatever I needed to learn, asked me some questions, believed in me, told me I could do it, and off I was again. And what I would say is that, again, I don't have a scientific study here, but it strikes me that kids who feel successful in mathematics have a system and a support to catch up when they fall behind. And kids who don't feel successful in mathematics, they have the accumulated experience of always being 10 minutes behind. If you're 10 minutes behind every day for a year, your confidence is shot and you don't understand. And so I would say that the question I always ask myself is, how can we build for all kids systems so that they can catch up in a calm and supported fashion, which we don't really have in math teaching and learning today across the country.
Well, thank you for bringing that up. Today, we're going to be discussing your new book, which comes out August 6th, the week that this episode will launch. It's titled Math Mind: The Simplest Path to Loving Math. And in it, you talk about how you've created a nonprofit called Zearn, which is the top rated math learning platform for elementary and middle school children. What inspired you to dedicate your career to improving math education?
I was really the arms and legs of my fellow co founders who are amazing teachers. So I'll share the stories of my co founders. They had taught in schools for 10, 20 years and had really focused on serving students who are often not well served by our public education system. And one of the main things they did in their classrooms is they got jaw dropping math results for these kids. And they proved the possible. They proved that with the right support, all kids can succeed in mathematics. But their work was happening in single classrooms. And so the question really was, how do we scale? How do we scale this broadly? One of my co-founders asked a question at the outset. He said, what if we put the best math learning online for free for everyone? Could we change the world? And as a child, my parents are both refugees from the partition of India, which is one of the largest refugee crises in human history. 14 million people changed sides of the border between Pakistan and India, and several million people died in the course of a summer. And so as a kid growing up with all of my family on both sides being refugees, I saw how important an excellent education, and particularly an excellent math education, was to rebuilding your life, to economic prosperity, to opportunity. And I also saw how lucky a person was to get access to that it wasn't a sure thing that you were going to get access to an excellent education. And that just always troubled me as a kid. It was always something that I wanted to think about, work on, help. But when I began talking to my co-founders, I actually worked at Bain & Company, and I worked for large companies, large tech companies, helping them with all kinds of problems like digital transformation. But these friends of mine, as they shared this idea that technology could augment the quality and access of math teaching and learning that kids could get, that technology could complement the important and hard work of teachers, the idea just electrified me, and it still does. I've been thinking about this idea for 12 years, and I still think that question that one of my co-founders asked, which is, what if we put the best learning content up online for free? Could we change the world? That's still one of my favorite questions I've ever been asked, and it's a real privilege to get to work on that question still today.
I just have to ask, when you were at Bain, did you ever work at Dell?
So we can't share our clients, but Dell was one of the legendary clients, and the teams that got to work at Dell loved it. But I signed an agreement that I can't share who my clients were.
I got to work very closely with Bain when I was at Dell.
Yeah.
And it was almost for us a musical chair of strategy consultants. It seemed every year we would go from Bain to Boston Consulting Group to McKinsey, back to Bain. And so I had the opportunity to work with all of them, depending on what the project was that we were doing. But
And
Bain
obviously,
was helping.
Bain was the best, right? Obviously, John. Just
Well, Booz Allen was the best because that's where I used to work. But no, but Bain was great and helped us really work on our strategy of figuring out what the new Dell was going to look like as we moved away from being just a hardware company into services and software and other things. So really helped me think about things in a completely different way.
Mhm.
Well, I want to go back to your book because in it, in the introduction, you write, most kids hate math, and what they're taught is that math hates them back. Implicitly rather than explicitly, our way of teaching communicates to the majority of students that they don't have what it takes to be good at math. Can you explain that in a little bit more detail and why you feel that way?
Thank you for that question. What I'd say is that math learning is full of myths. And those myths they're every day, they're pervasive. And the first myth is that there are some kids who are geniuses, they are math kids, and those are the ones who are going to succeed in math. And everybody else, it's not for you, don't worry about it. Someone else can do math and you can do everything else. That would be the same as, imagine if we brought a bunch of, I don't know, we're hanging out with a bunch of first graders and only some were going to learn how to read and the rest were going to be illiterate. And that's perfectly fine. And don't be mean to them. They have other things they can do. So the first giant myth is this myth that innumeracy is something genetic or innate, which is just absolutely not true. And the best evidence of that is that there are other countries where the majority of children come out of their schools numerate. That isn't what happens with our schools. So, it's like we have population scale proof of that first point, that all kids can succeed in mathematics. So that's the first myth that's pervasive. That myth alone is a big deal. It's in the movies, it's in books, it's in the way we talk. It's in the way we talk to our own children. The humans we love the most on earth, we talk to our own children like that. So it's a big problem. If that was the only problem, that would be great, but there are even more problems, and they go into the daily way we understand and learn math. And so there are three myths that I'd love to kind of expound on a little bit. The first is that math is only for those who are really fast, who can calculate very quickly. And in fact, that is what math is. Math is just calculating very quickly. So if you can't calculate quickly, a lot of things go on in your brain. One is you think, why doesn't a calculator do this? Why would a human who can calculate quickly be advantaged? The second is you think, let's say it's okay, well, who can finish this problem the fastest? what you start to think is that there are problems that you can complete in a minute, and those problems are for you. And there are problems that you can't complete in a minute, and so those problems are for someone else. And what that does is it saps any persistence or any of the problem solving mindsets that we need, right? Like when you think about working at Dell and the problem solving mindset that you wanted from your team, you didn't want them to work on a problem for 1 minute and give up. So that's the first myth, this myth of speed. The second myth is the myth that math is about memorizing tricks. That's kind of the empty calories of learning. So it is the case that sometimes you go into an exam and you just memorize a bunch of formulas, you plug and chug, and you hope for an A. But that is not the whole discipline of mathematics, right? So imagine if I'm in fourth grade and I have a reading test and I memorize 500 words, but I don't know how to read. So I can't look at any word and decode it and read it. But I memorize 500 words and then I forget them because that's not a strong foundation of how the human brain works. And so then I don't know how to read the next week. That's absurd. Similarly, you can learn math so you don't forget it. You can learn it like reading. And a lot of adults and children do not know that. They think math is a series of tricks to memorize. 2 divided by 1/2. Well, flip and multiply. Have they ever thought about what does a whole number divided by a fraction even mean? No. Why would you bother knowing that? You just memorize, you go to the next thing. And then the last myth, and I think this one is the one that takes all the joy and love of math away, which is that there's only one way to get to the answer. Now, don't get me wrong, there is only one answer. 2 divided by 1/2 is only 4. There's no other option. But there's a couple ways you can solve that problem in your mind. And giving children, empowering children and adults with the creativity and freedom and enjoyment of solving a problem the way they want to has huge amounts of value. But a lot of children, they really think that I'm not fast, I can't memorize enough, and I can't do it my way, I have to do it your way. And so I hate math. And I think that's a reasonable thought. It's just none of those things are math.
I did this interview a while ago. I'm not sure if you ever listened to it or not, but it was with a long-term mentor of mine, Captain Wendy Lawrence, who's a former astronaut. And Wendy has gone around the United States talking to kids for the past 2 or 3 decades about giving yourself permission to dream your dream. And she said math is one of the most critical areas where kids tend to give up on themselves the first time that they face any adversity.
Yeah.
And she loves to tell them the story that she did extremely well when she was at the Naval Academy, was at the top of her pilot class, et cetera, et cetera. And then when she went to MIT, she realized just how smart everyone at MIT was, and that for the first time in her life, she was on the lower end of the bell curve. And she was really suffering with her classes to the point that for the first time she was starting to fail. And she said, you have a choice, regardless of what your age is when you hit that point. Either you can succumb to the failure, or you can double down and figure out how to overcome it. And in her case, she started setting up private sessions with her professor to help better train her mind how to get through the complex math that she was facing at MIT, and obviously ended up prevailing. But she said that's one of the biggest things that she sees is today when kids face adversity, especially when it comes to math, there's this natural tendency to give up rather than doubling down and trying to figure it out. Did you find that to be the case also in some of the research that you have found?
Absolutely. And look, at the end of the day, kids are smart, right? So you walk into a middle school and there's a poster on the wall that says, making mistakes is how you learn. And it's just a lie, because when they make mistakes, they get punished. And they live in an environment that says that when they make mistakes, it means they shouldn't try. It's not like kids, they don't take, why do they do this in math, but they don't do it in other things? It's because that's what adults are telling them. And so we have to be really careful about what are the ways in which we support kids so they actually want to double down and try. And so the first is belief, right? In the case of Wendy, your mentor, what you're sharing is her professor, she took extra time with her professor, right? Just like your mom gave you extra time, just like my dad gave me extra time. That professor would not have given her extra time if if the professor didn't believe in her. And she also wouldn't have, if she went to the professor's office hours and said, "May I please have some extra time?" And he said, "Nope, you're just a complete dope. You should leave this school." That would not have gone as well for her. So, whatever that individual did, they showed with their actions that they believed, and then they gave her the extra support. I think about the countless things that children do. If you are playing sports and you want to get better at batting or pitching, you wouldn't say, well, there's some kids who are just magical pitchers. They were born like that. I'm 9 years old. I'm not born like that. So I'll just give up. You'd ask your parents to take you to a field and you'd say, can we practice? Can you help me? Can you help me? I want to get better. But the world of math still has this narrative where kids give up. And I can tell you so many hazing stories. Like I told you the story of my sixth grade teacher who did not haze me. He did the opposite. But I have so many stories and through the course of my high school and college career, I ended up doing advanced mathematics. I ended up in the kind of honors track or the AP track. And my God, the hazing that you would get. I remember in ninth grade, there was an honors math class that I joined, and the teacher opened on the first day with not enough chairs for the number of children enrolled in the class. This was already a selective class. There were so many cutoffs to get into it, including a test. So these were children who were motivated and crossed some threshold. And just to haze them further, on the first day, he didn't provide us enough chairs. So I got a chair, but a few of my friends were standing while he opened the class saying, "This is the only path to BC Calculus, AP, this class. You have to get an A. And not all of you will get A's. And I'm just showing you right now, with the number of chairs here, the number of kids I'm expecting to not make it, but it could be more." That was the first moment of the class. How is that going to make children feel when they fail a test, when they're struggling in homework? What it means is that I need to be sorted out of mathematics. I can't learn. And what I really admire about your colleague Wendy, or your mentor Wendy, is she was courageous. She was brave. She was like, "I need help. Help me, please." And it takes so much. It took Mr. Snyder asking me to come over to his desk for me to be courageous enough to ask for help. I'd been struggling for weeks. I knew I needed help. I just wasn't courageous enough to ask for it. And so I think that unfortunately, this is what math is like, though I will say it is shifting. It's a lot different than when we were kids. It's getting much better.
So I was hoping, given that backdrop, you could talk about some examples of countries or regions that excel in math education, what we can learn from them, and understand why the US is lagging behind these other countries when it comes to math education.
Thank you for that question. I love that question because I think our best approach forward is to look at what's working both in our country, because there are places it's working, and certainly what's working in other countries like a Singapore or a Japan. And we shouldn't get overly attached to any one example because each one will have differences. There are cultural differences, there are context differences. But if we step back and look across all of them, there's a lot of emerging research and learnings about how to build a math mind. The one thing that's funny is a lot of the research is American research conducted at American universities like Harvard University, but then applied in other countries. So it's just important to remember that even when we see the results in other countries, it is actually our scientists and our professors that are coming up with this research. And in the book, I talk about the 5 methods to build a math mind. And I think that is the synthesis of the research we know today. And there still is more research to be done. So I don't think that we've gotten to the place where we know exactly how to build a math mind. We know all the parts, and we just should be implementing. But we certainly are at the place where we know enough that we should be implementing more consistently. So, for example, in March, I happened to be in Singapore, and I spent some time with the Ministry of Education visiting classrooms. And I spent 3 days with them. I think I heard the word believe. We believe in kids from teachers, principals, math coaches, the Ministry of Education officials. I think every day, each person said it 20 to 30 times. So by the end of it, I was like, believe. It's just over and over. I heard that word. And I think when you look at exceptional results in US classrooms, you are going to see the beginning, which is belief, the belief that kids can do it. And so I'd say the first is that kids need to believe, and they need to feel that they belong in a community of math learners. So I love the perspective of an astronaut, right? Like somebody who is so gritty, so accomplished, has overcome so much adversity, struggling at MIT, and still having the courage to go to her professor and ask for help. So how does that arise? How that arises is that often that person feels they belong in a place, right? In that sixth grade classroom I was in, I did not feel that I belonged. I was a new kid. I was struggling in all my classes, not just mathematics. I didn't have any friends. I was just brand new at the school. And so when Mr. Snyder took the extra time to talk to me, he was inviting me in to belong. So this idea of belief and belonging, you see consistently as the basis of any math achievement we see in this country or in other countries. So I think the second thing that we see is that this idea that you don't memorize your way through, you understand. And there's a very specific way that we teach understanding consistently, and that's with pictures or objects, right? So a simple example is what I was talking about before, which is this idea of 2 divided by 1/2. So when you divide a number, if I take the number 10 and I divide it by 2, will the number be bigger or smaller? Well, it's going to be smaller. When I divide something, it gets smaller, and I get the number 5. Well, when I divide 2 by 1/2, the number gets bigger. It becomes 4. Well, what's going on? How come it's getting bigger? Can you tell yourself a story? Do you understand what 2 divided by 1/2 means? Well, let's try to tell ourselves a story. Okay, I have twins. I have 13-year-old twins. When they were little, their friends would come over. So it was not uncommon for me to have 4 children at our apartment. So imagine if I have 2 very big cookies, but I have 4 little kids, and I don't want that much sugar going into their bodies. So I'm going to take those 2 very big cookies, divide them in half, so I can have 4 pieces for each of the children. Okay, I can tell myself a story. I know what's going on. That is the understanding that pictures, objects, real world contexts, kids cannot understand mathematics unless we bring that in. Same with adults, by the way. Same with mathematicians. Same with anybody. They need a picture. Now, that picture could be a parabola. It can be something more abstract as the math gets more complex. And I'm not saying you're going to draw your way through the SAT, but if you can't tell me what's going on, then you don't understand. And you could understand. And when you do, you'll enjoy the mathematics. You'll be able to apply it. Your learning will be durable. You can take it to another place. The third thing that we see in kind of strong performing math classrooms is kids feel the agency to make an easier problem. So the example I like to share is the calculation 35 times 18. If you learn math in a really disempowering way, you think there's one way, you get out a paper and pencil and you write out the algorithm, you stack the 2 numbers and you multiply through. Kids who've been taught to make an easier problem, and it's sometimes by their mom or their dad or their additional support, they might say, well, I don't really want to do the algorithm because that's just irritating. And so, but 35 times 20 is 700. And then I have 2 extra 35s, and 35 times 2 is 70. And so 700 minus 70 is 630. So I'm just not even going to do the algorithm. I'm going to make an easier problem. Why does that matter? That matters because kids are enjoying the math, they feel agency in the math, and they actually are just using less brain energy. And so it saves brain energy, it saves cognitive load for the harder math in front of them. The fourth thing we learn is that it comes back to the adversity piece that you shared of making mistakes, which is kids' interest and desire to try a different way. I love like the video game example, right? So if you watch children play video games and they lose, they don't slay the dragon. They are not like, okay, well, I'm not a video game kid. I can't slay the dragon. They're like, okay, we should try this a different way. And another thing that they'll often do is talk to their friends. So they'll ask their friends, well, how did you do it? Well, should we try this way? Should we try that way? They'll engage in excited, enjoyable problem solving. And the ego goes away, right? They don't feel humiliated. They don't feel embarrassed. They might for a second, but then they're going to jump in and be curious and be talking and really engaging in the conversation around problem solving, around trying a different way, which you do with everything, right? This morning, my coffee machine wasn't working. I didn't decide I wasn't a coffee machine person. I just tried a different way. I just kept trying. And then eventually I got a cup of coffee. And I didn't get like overwhelmed by some sense that I'm dumb. I just kept trying. And the last thing that I will say is that math is a language. So if you wanted to, let's say, learn French or Japanese and you practiced once a month, you would be very bad at French and Japanese. It just doesn't matter how smart you are or how great you think you are. You just have to practice. And so numeracy is like a way that the brain works. And you just have to practice, just like reading, you have to practice. And one of the things we do in math practice is we make it really boring and not fun. So when I think of math practice, even though I build Zearn and I try to engage in a world of enjoyable, fun math practice, one of the images I conjure is a worksheet with 40 long division problems, because that's what I had to do when I was little. Why? That's not fun at all. And so we have to practice math, but we have to make it fun.
I'm glad you brought up numeracy, because in the book you talk about the fact that numeracy is as crucial as literacy. And you gave a great statistic in the book. You write that since the 12th century, the system to represent any number on Earth with those symbols is universal. There's no Tower of Babel in math. We all can understand one another. It's an ingenious structure that always works. And I don't think we think about that. We have all these different languages across the world, but we really only have one way that everyone uses math. And that's really a unique and binding force if you think about it.
Isn't that the coolest thing ever? That before the 12th century, so the kind of the history of the numbers that we use 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and the decimal, and those symbols represent any number that we can conceive of. The history of that starts first in India, and that's where that set of symbols are invented. And then they find their way to probably what is modern day, like Uzbekistan. It was an area called Khwarezmi. And then they find their way all through the Muslim world and the Middle East, North Africa. And then finally they make it to Europe. And while that seems slow, that took from the 8th century to the 12th century, that seems slow. You have to understand there's no internet, there's no modern telecommunications. And so it's basically one way of representing numbers that's so useful that it goes viral. And it's not just useful to intellectuals and mathematicians. So the word algorithm is based on a man's name. His name was Al-Khwarizmi. And the Latinization of his name is the word algorithm. And so he was a great mind, a great intellectual, and he loved pure mathematics and proofs. And so he really loved that structure. But what made it go viral were actually merchants and shopkeepers who just thought it was easier to use. It was easier to use than, for example, other systems like Roman numerals, right? Try adding using Roman numerals. You can't stack them. And so it's super exciting that we can all be numerate together with the same numbers and symbols. Excuse me. When I was in Japan last summer watching math classrooms, I don't speak a word of Japanese, and no portion of math instruction is in Japanese. And so I was there with the chief academic officer of Zearn, and we had with us a translator who was whispering the Japanese into English in our ears. And we were watching a 10th grade, like an upper level math class. It was so riveting. And because we could follow the mathematics, just the numbers and the work, the written work of numbers going up that the teacher was representing and the students were representing, we kindly asked our translator to stop talking because it was so riveting to watch the mathematics and enjoy the mathematics. We didn't need the Japanese language translated to English. We had math that we could all universally understand. And she got flustered. Am I doing something wrong? And we were like, no, we can follow it. And so please just don't talk so we can enjoy ourselves.
No, it is funny because whenever I have traveled to Japan, it's as if your meetings take 3 times as long as they should, but it's because 3 translations take place.
Yeah.
And it is a tiring process. So I can sympathize with you finding an easier path that everyone understood. In the book, you give out 6 different benefits that math provides. And the first one you talk about is problem solving. And in the book, you explain that problem solving is a distinct cognitive experience. You say instead, we ask what is happening in the problem. It is not mindlessly following a single perspective set of steps. The way to solve the problem in every problem is to understand what is happening in the problem. And you say that your advice to problem solving is to make a movie in your mind, which I found quite interesting. Can you explain what you mean by this? Because I think it's something that could be useful for people who are listening to undertake problem solving themselves.
Yeah. Thanks, John. Thanks for that question. Yeah, so I get the chance to go to math classrooms. I've been to thousands of math classrooms. And what's interesting is the children are interested in pleasing the adults around them. That's often their motivation, especially in school. And what happens in that desire to please and then not really understanding what's going on is this totally distinct cognitive process from problem solving, which I would call answer getting. Answer getting is where you don't really understand what the problem is asking, but you think you have the formula to apply. You apply the formula and you say, am I right? Well, why don't you check your work? Why don't you think about it? Are you right? How would you know if you're right? Math, unlike other fields, has a dimension to it, which, to use a technical term, is called autodidactic. What does that mean? That means you can check your own work. So if you're asked to multiply 3 times 6 and you've guessed that it's 18, you can check your work. You can take 18 and you can divide it by 6 and see if you get 3. And so that's one of the dimensions. In order to check your work, you'd have to understand what's even being asked. And sometimes when word problems are presented, you can't understand it when you first read it. And so what I often encourage children to do is to reread it and make a movie in your mind of what is happening. Don't read the problem and immediately think about what formula you need to apply and how do I solve this, but just take a breath, read the problem, and make a movie in your mind. What is happening? I don't know that much about literacy and reading instruction, but one of the things I've heard great reading teachers say as children are read aloud to is you ask children to close their eyes and visualize everything that's being read aloud to them, and it makes them stronger readers. And what I'd say is use a very simple problem in the book, which is something like 3 bags of marbles cost $18. How much does 1 bag of marbles cost? And children will multiply 3 times 18. So they'll think 1 bag of marbles costs more than 3 bags of marbles, and they'll put that answer down. And that's completely unreasonable. If you close your eyes and you picture a giant bin and there are marbles and there's a sign that says 3 bags cost $18, and you kind of just take a second and think about that, you are not going to make the mistake of thinking you have to multiply 3 times 18. but we skip that cognitive step, the step of understanding.
Thank you for sharing that. And I think, as you explain in the book, the other thing that we tend to do is when we're problem solving, we tend to make math seem like it's a competition. Use the example of 63 plus 37 that a teacher would ask, asking for kids to raise their hands, where they could do it the opposite way, which is if you are looking for an answer of 100 and you've got 67 and you want to add 37 to it, what is the process that you go about to make those two come together to equal 100, which is a different way to think about it completely. You also mentioned one of the benefits, and this one was my favorite one, that math can soothe the soul. Can you elaborate on this idea? Because I think it has a lot to do with creativity and another thing that I think is important for kids, which is learning musical instruments or performing different variations of art.
Mhm. So math is behind a lot of the beauty we see. So beautiful building, beautiful song, what the part of the beauty in it to us as humans is the patterns that we see. So one of the things, there's a few things we intrinsically enjoy, and one of those things is that we love patterns. We love to find them and discover them. So if you're kind of listening to a song and then you discover the pattern of the song, that you may find that beautiful. Or if you think of a haunting melody, like a melody you really enjoy, there is a mathematical pattern in that you're enjoying. So math literally illuminates beauty around us. And I think that it's really important to know, I would say to know two things. One is that math is beauty. There's beauty in mathematics, and that it's for everybody. It's not just for some special group that you're not a part of. Ancient religions all incorporated mathematics as like maybe the way that they structured an altar, or the way that they, special sort of important numbers, the number of prayers you would say, the time of day you would say those prayers. So it's always been something that is beautiful and mystical in human history. And it kind of actually is. I would say one thing that I always wonder about, particularly you mentioned calculus. So calculus is a field of mathematics that is so astonishingly beautiful that it's kind of hard to believe that humans invented it. So if you think about it, calculus is the mathematics that can most efficiently explain motion on Earth. So if you think of Newtonian physics, a car is traveling at 60 miles an hour, then a car speeds up to 70 miles an hour. That change in velocity is acceleration. And calculus is the mathematics that most efficiently helps us determine what that acceleration is. Well, how did humans invent that? Because we didn't invent gravity and we didn't invent motion on Earth. And so if you actually start to explore some of the deep mathematics that explains how the universe works, it does get mystical. It is mind-blowing. And then you start to think, are humans inventing math, or are they just actually discovering math? Is math already there as the structure of the whole universe that we live in? Those are ways in which math can soothe the soul. Other ways are puzzles. Who doesn't love puzzles? And that actually is what math is. Math is full of puzzles. Math is not torture. It's not memorization. And puzzles are things that actually create a dopamine hit into the brain. That aha moment when you solve a puzzle, that's what math is full of for all of us.
Shalinee, thank you for sharing that. And last question I wanted to end on was, you write that we all have a role in creating a numerate society: parents, teachers, school administrators, sports coaches, journalists, filmmakers, etc. But to get there, the numeracy revolution needs the same passion and purpose of the worldwide literacy movement, which is why the United States has been resparked recently. So how do we get kids to start learning the captivating yet believable idea that all kids can learn and love math, like the movements are going about loving reading, for instance?
I mean, the thing that I would say what I would say to parents is, just because if math didn't go well for you, don't carry that forward. Don't let your kids miss out. There's too much they're going to lose. So if your child in fourth grade doesn't do well on a math test, don't say, that's okay, I wasn't good at math either. Don't say that ever. Never say that. That would be like a child who, I don't know, wasn't lost their baseball team lost a baseball game in Little League in fourth grade. And then your child came home and you said, that's okay, I lost all my Little League games too. Don't say that. That's not what the kid needs to hear. That is not helpful. What you should say is, that's okay. We all make mistakes. How can I help you? And actually believe in the kid and then give the child support. So I think that is the number one thing, that if we can switch our orientation as adults supporting kids, that I think is going to have the biggest and most lasting impact. I think the other question to ask ourselves is, why do we think so? What I would always say, the way I frame it is, when children can't read, we get mad at the adults. And when children can't solve math problems, we don't get mad at the adults. We just absolve the children of building a math mind. And we think adults pushing on it are being mean to the kids, right? That's so weird. And I think we should have much higher expectations of the adults, right? So as I shared earlier, if you thought that a school district believed that, let's say like a large school district in your state, they think it's completely reasonable. The kids come to elementary school, some of them learn to read, and the rest leave illiterate. That's fine. Like, why are you being mean to these children? We think that's okay. We don't think that's okay. Sorry, because that is not okay. But with regard to mathematics, in your same school district, a bunch of children come to middle school and they finish middle school, and a bunch finish enumerate. A lot. Incapable of passing algebra. That's not okay. And so we just have to have those same expectations and beliefs. And it is a step change. It's a big change from how we grew up that our kids deserve.
So if there's anything I want people to take away from today's entire discussion, it's your affirmation that every kid is a math kid. And I think that this is extremely important because math proficiency is a prerequisite for success, not only today, but more importantly, in our tech-dependent digital world that these next generations are growing up in, that's only going to compound in its advancements and its speed. If people want to learn more about what you're doing, what are the best places for them to go to?
Well, so Zearn.org is the platform if you have kindergarten through 8 kids through 8th grade, and anyone can sign up and create a free account, a teacher or parent, and use all of the learning content. So that's a great place to support your kids with that kind of extra help, John, that your mom gave you, or the extra help my dad gave me. And the other thing is, please, if you're interested, check out the book, Math Mind, which you can grab anywhere you buy your books.
Well, Shalinee, thank you so much today for coming on the show and for sharing this very important topic with our audience. It was a pleasure to have you.
Thank you, John. Thanks so much for having me, and thanks for your awesome questions.
What a fantastic interview that was with Shalinee Sharma. And I wanted to thank Avery Books, Ashton Ballard, and Shalinee for the honor and privilege of joining us on today's show. You're about to hear a preview of the Passion Struck podcast interview that I did with Rob Kaliworowski, a distinguished leadership coach who combines neuroscience, mindset coaching, and high-performance strategies to unlock leaders' potential. Rob, an MIT grad and former water polo team co-captain, delves into the mask that we wear, toxic leadership, and how leaders can foster high-performing teams as well as authentic organizational cultures. Discover powerful insights and practical solutions for transformative leadership.
There's a Stanford study from 2015 that said the way that companies manage attributes 120,000 deaths per year in the United States alone, and 5 to 8% of the total annual healthcare cost. That's crazy. It makes it the 5th leading cause of death in the United States, is how we manage folks. Not to mention the fact that happier employees do better and more productive and you make more money. Toxic leadership is killing us, and it almost killed me.
The fee for this show is that you share it with family or friends when you find something useful or interesting. If you know someone who's really interested in math, or maybe is not interested in math, and this episode can be an inspiration for them, then definitely share this episode with Shalinee Sharma with them. The greatest compliment that you can give us is to share the show with those that you love and care about. In the meantime, do your best to apply what you hear on the show so that you can live what you listen. Until next time, go out there and become passion struck.